Hello ladies and gentlemen, it's Mr Tsebe again, and we'll be evaluating Laplace transform of cos 2t. But we know that Laplace transform of cos 2t, without wasting time, equals to our formula e minus st times ft. In this case, our function of t is actually cos 2t dt. And this is the same as limit of b, which goes to infinity, of this integral minus st. So I can just substitute cos 2t where I see ft, cos 2t here dt. So, but if you can check this is a product of two functions, so we have to integrate by parts. I can just say this equals to yo times v minus v du. That is our formula for integration by parts. So I'm going to let my yo to be equals to cos 2t. So now I can differentiate both sides, du with respect to dt. So if I differentiate this, I'm going to get minus 2 sine 2t. So if I want to make du the subject of the formula, I have to multiply by dt this side and by dt this side. So my du will be minus 2 sine 2t dt. So I got for du and u. So right now I can let my dv to be equals to e minus st and dt. So if I integrate this side and I also integrate this side, so my v will be minus e minus st all over s plus c. Right now I can just substitute on our equation, which is u. But what is my u? My u is cos 2t multiplied by minus e minus st all over s, which has a limit of 0 all the way to b, minus this integral. What is my v? Minus e minus st all over s. But this integral starts from 0 all the way to b also, multiplied by du. But what is my du? My du, we found it here to be minus 2 sine 2t dt. That's what we have in there. So let us evaluate this guy alone. So this will give us cos 2 into b. B, it is our infinity, don't forget, minus s b all over s minus cos 2 into 0 in this time, minus e minus s into 0 also all over s. So we don't care what cos of infinity is, but if we can check here, we will understand from our first session that when this b approaches infinity, this whole thing is 0. So 0 times cos, it is also 0. So here it will just give us 0. Negative times negative, it will be positive. Cos of 0 is 1 multiplied by e. Anything raised to the power 0 is 1 all over s. So I'm getting 1 over s for this guy. So it will be 1 over s here minus negative, it's negative. So, but 2 and s are constant. I can take them out of the integral of 0b e minus st sine 2t dt. But if you can check sign, you'll realize that this it's actually the Laplace transform of sine 2t. But we don't want Laplace transform of sine 2t. We want what? Laplace transform of cos 2t. That's what we were asked to evaluate. So let me erase this part. That's what we were asked to evaluate. So we are having 1 over s here minus 2 over s into what? The integral of 0 into b e minus st times sine 2t dt. That's what we are having there. So we want to evaluate this guy alone. We want to evaluate that guy alone. So if we evaluate that guy alone, we are going to be having 0 infinity minus st times sine 2t dt. But you will see that this guy has a product of two functions. And then using integration, we don't actually have an exact rule. That's why we are going to use integration by parts. And this is the formula. So I'm going to let my sine 2t to be u. So if I differentiate this guy, it will give me 2 cos 2, which is du all over dt. If I want to make du my subject of the formula, I'll multiply by dt this side and dt that side. So I'll be having 2 cos 2t dt equals to du. That's what I'll be having. But for dv, it will be equals to minus st and dt. So if I differentiate, integrate this guy, and then also integrate est dt, I'll be having vs, since my s is constant, I'll be having minus e minus st all over s plus c. So right now, what we can do is to actually substitute in our equation. So when we substitute in our equation, my u is what? Is sine 2t multiplied by v, which is minus e minus st all over s, and it has a limit of 0 all the way to b, minus this integral, which starts from 0 all the way to b. But my v is minus e minus st all over s multiplied by what? Multiplied by du. But my du is what? 2 cos 2t dt. That's what I'm having for my du. So now, let's evaluate this guy. If we can evaluate this guy, when we substitute b on this guy here, this will just go to 0, and this whole thing will give us 0. And when we substitute 0 on s, this will also go to 0. So this will just be 0. This guy, you can evaluate it yourself, you'll see. Negative, negative is positive. So 2 and s are constant. I'll be having 2 over s out of the integral, which starts from 0 to b. But my e is minus st times cos 2t. Then this is the Laplace transform. 2 over s is the Laplace transform of cos 2t according to our formula. So this guy, don't forget, is this whole thing here evaluated. So I'm going to substitute it there. So I'll be having 1 over s minus 2 all over s into 2 over s Laplace transform of cos 2t, which is equal to Laplace transform of cos 2t. Don't forget, guys, this whole thing that we are doing now, it is equals to Laplace transform of cos 2t. So now I can just let my Laplace transform of cos 2t to be b. I can just make it b, or you can make it s, depending to what variable you love. for me, I love B. That's why I'm using B in all the cases. So let me erase this part now, so we can evaluate the last part. So I'll be having 1 over S, as we can see, which is this guy, minus 2 over, but what is 2 times 2 is 4, over S squared, because of S times S. But my Laplace transform of cos 2t is what? I said is B, which is also equals to B on that side. But I can, for me to remove this, I can make the exponents the same. So S times 1, it will be S squared minus 4B times S. S times this whole thing. But S times S is X to the exponent 3, which is equals to B. So if I multiply by S to the exponent 3 this side and S to the exponent 3 this side, so this S will cancel out this S. So my S2 minus 4BS will be B times S to the power 3. But my S squared will be the same as B S to the power 3. This 4, when it goes to that side, it becomes positive 4BS. But my B is the subject of the formula. My B is our common factor, sorry. Even our S, but remember we are evaluating Laplace transform, which is B. So my S3 plus 4S, that's what I'll be having in the brackets, over this part is S squared. So we can divide by S to the power 3 plus 4S. S to the power 3 plus 4S. So that's what I can do. This one will cancel out this one. So my B, which is the same as Laplace transform of cos of 2t, will be the same as S squared. Or I can just say S times S. If you can check here, you'll realize that S is a common factor. I can factor out S, so I'll be having S squared plus 4 inside the brackets. So 1S will cancel 1, so I'll be having S over S squared. I can just say 2 to the exponent 2. So guys, this is how we evaluate Laplace transform of cos 2t. And if you like this session, please like this video and then also share with your friends. Thank you.